Good morning, everyone, and welcome to PRT327. My name is Eric Schultz, VP of Product Management for Trend Micro, and then joining me on the stage in a little bit will be Shaman Kruthnamurthy. Sorry about that. So he'll be up here from the IoT, Consumer IoT GM from AWS to talk a little bit about some IoT stuff as well. Talking about design patterns for distributed client-server systems via IoT. So Trend Micro is on our journey to adopt IoT in a kind of what we feel is a unique way. And I wanted to walk through our journey and some of the problems we encountered, how IoT has helped us, some of the limitations that we've overcome, et cetera, of using IoT to basically replace client-server networking that the old traditional what some customers would call a heartbeat or long polling or agent pings the cloud and gets a job like that. So how have we replaced that with IoT? If you haven't heard of Trend Micro before, cybersecurity company, we've been in business 30 plus years, about 500,000 customers globally, global Fortune 10, or top 9 of the top 10, about 7,000 employees across the world, so a very globalized company. I'm going to skip some of them, except the very last one. I will get in trouble if I don't highlight that AWS did recognize us this year for Global Partner of the Year for AWS Marketplace. So the stuff I'm talking about today, the technology that Trend builds for cloud that we're talking about, all available through the AWS Marketplace to help delight our customers and reduce friction that way as well. So now let's get right into the content. Let's talk about the problems that we wanted to solve as a company. We wanted a modern, scalable cloud networking for client-server communications. We had to handle agent provisioning, authentication, overhead. Those are really undifferentiated services. They're just core. You have to have them, but they don't really provide standalone value. Like a customer won't pay Trend just for those two things, right? Those aren't our core value proposition to our customers, but they still have to be done for our product to function properly. We needed bidirectional data transfer in near real time. If you've ever heard of EDR or endpoint detection and response, where you have basically think of it as a security camera inside your laptop or server, recording all the file opens, file writes, network connections, et cetera. And how do we get all of that data to the cloud for processing in near real time? But more importantly, be able to send tasks back to the endpoint to take action or do something like a remote shell for troubleshooting, incident response, et cetera. So we needed bidirectional communication very, very quickly because time is of the essence in that type of a situation for security. We have multiple data transfer patterns. So we have one-to-one, right? So we have a server needs to talk to, the cloud needs to talk to an individual agent, but we also have where the cloud needs to send a job to 10,000 agents. But we also have 10,000 agents that need to send all of this data to the cloud in near real time. So we have all those different data patterns that we need to be able to accommodate at scale. Going right into scale and manageability. One of the goals that I had asked the team to do is, can we support 100 million agents? We're not there yet, but that was what we wanted to architect for. We didn't want to architect for 1 million or 2 million, because we're already well past that. We wanted to architect for the number that would hit our long-term growth targets as a company. So that's where we set our goal. And when you start getting to that scale, that's where you start running into some unique challenges that we'll talk about in a bit. We also didn't want to manage fleets of EC2 instances with load balancers, with ELBs. We do that today, and I'll talk about that a little bit on our journey. But we knew we couldn't linearly scale that because that added operational overhead that also impacted our costs significantly. So we needed to find a way to solve that problem as well. And then finally, we have a lot of agents around the world already. So we needed to be able to easily integrate into our current agent, into our current customer base, for a transition period. We couldn't, if you've ever worked with a customer or yourselves where you don't upgrade to the newest thing all the time, every time, or a vendor doesn't say you must upgrade on this exact night because they're flipping the switch. We can't do that. We had to have a transition period, and we had to schedule that, or we had to provide that opportunity to our customers. So there's over 50 million agents today that we need to handle this for, so it's not a small number, right? Going back to those challenges that I just talked about. We've got to be able to transition our customers slowly at their pace, not at Trend's pace. And then finally, the problem, this was an interesting one, enabling our business to run faster. So the endpoint protection and the endpoint security market in general, cloud workload security protection, it's adapting over time, right? There's new functionality being added. How do we enable our teams, the Trend teams, development teams, to run faster? We don't want to recreate things that have already been done or done well, right? So one of the goals of the endpoint team with IoT, as you'll see in a bit, is to be able to make it modular where other teams inside of Trend can build additional functionality and not have to worry about server cloud communications, network retry, any of that. That's all handled through this core framework that we're building so that those teams can run faster, which means we can delight our customers faster. So we'll talk about why a little bit more too. I'll go a little deeper. We had a lot of data going to the cloud. On average, the average endpoint with our telemetry is between 25 and 30 megabytes per day. That's a lot of data going to the cloud. What that means is longer connection times. If you're going through the traditional elastic load balancer with EC2 instances, more data means the connection gets held open longer. The longer the connection gets held open, the less connections that server can process, which means now your scale starts dropping. You can't process that many connections simultaneously. So simultaneous communication or simultaneous connections were one of our challenges that we had to solve. The one-to-one data transfer that I talked about, it's not as efficient for some data patterns. When we need to send a job, when I wanted to do something like quarantine this or block this URL across the environment very quickly because of ransomware or whatever, I don't want to have to create 50,000 jobs where each agent gets an individual job. I want to create one job, publish it with a destination of 50,000 agents. Much, much more efficient for our cloud processing, much more efficient for our customers in terms of bandwidth. We also wanted to run faster, more dev, less ops. Like I said earlier, I don't want to scale the operations team linearly as we keep scaling up our fleets of EC2 instances. We did the simple math, it wasn't scalable, it wasn't financially stable, or financially made sense for Trend as a business to keep our prices where they are for our customers. So it literally was causing us linear growth. SaaS growth, lots and lots of our customers are moving to SaaS. There used to be a lot that would keep everything on-prem with the data center. If you walked around the show floor at all, you would have seen all of the cloud transformation. AWS has many, many services to help you migrate to the cloud and make that easier. So we're seeing lots of customers moving to the cloud. But with that, they also want to offload the management application layer. They don't want to manage the server behind their cloud, behind their security applications anymore. They want that to be a SaaS application because we can release features faster for them. We're also pushing, because of the SaaS growth and how much we've seen, we're pushing the limits of our original designs. Our database schema, for example, the way our application interacts with the database, we start running into challenges at scale with database locking. Because as one node is writing to the database, it's locking part of that table, and then another node has to wait. So now you start getting into these race conditions at scale. So we needed to find a way to take certain parts of this data out of the core application where it didn't need to be able to remove those lock pressures. We also have a very existing mature business, right? So customers, like I said a little bit ago, I can't force a customer to upgrade on my timetable as Trend Micro. They have to choose when they do it, when it fits into their change management schedule, et cetera. So we have to be flexible and be able to support both their existing as we roll out this new technology. And then last but not least, endpoint is the front line of security in all reality. When I say endpoint here, I mean endpoint very broadly, including workloads, so cloud-facing web assets, et cetera. That's where the attackers are going after. You've got user endpoints, desktops, where your users sit and click on things, et cetera. So the endpoint is the front line. Lots of other layers, but if you look at this room, none of us are sitting behind a perimeter firewall right now, right? We're all sitting in a conference hall, but we're still potentially working. So the endpoint is that true front line. So let's go into some simple architectural diagrams. Now, these are very, very simple. They are meant to be there just to convey the top line. They are not architecturally accurate from what service is and what way the communications work, just for that caveat, because I know there's some developers in the room. Today, we have a monolith application, or sorry, originally, we had a monolith application in the cloud. We could run it on-prem, we could run it in AWS. Worked great. You got clients that have our agent installed. Windows, Linux, AIX, Solaris, lots and lots of versions of Linux. Those communicated through pools of EC2 instances sitting behind load balancers. All the configuration data, so the policies going to the agent about what the agent is supposed to do, as well as all of the event data about what was detected, was this completed on time, were updates successful, all of that was being fed back up through those pools as well. Some limitations of this design. It's a monolithic application, right? We couldn't run fast. We were running into bottlenecks internally because everything required this core monolith to be adjusted and enhanced and changed. And it was very tightly integrated with itself, which meant as we made changes, there was risks of breaking other things by accident because of just the way the dependencies worked. So we had very limited people that could work on it at the same time without risks. The database table locks at scale that I mentioned earlier. And most importantly, everything had to go through that core application. There are certain things like EDR data that I talked about earlier. That doesn't need to go through our core application. That needs to just get funneled to the cloud to our data lake. There's no need to be pre-processed or reprocessed in the monolith application, so there's no reason to route it through that and add additional load on that system. Fleets of EC2, those are still some limitations of this, right? We talked about that, or I talked about that earlier. Both connection count, data volume, and just scalability. And they get expensive at scale. Data transfer, in all reality, this only supports the one-to-one. So I talked about the different data transfer patterns before. This model for us only supported the one-to-one, which had some limitations for us, once again, once we get to scale. And then lastly, the agent provisioning and authentication. It's part of that monolith application in this case. So when an agent gets activated, when an agent calls in and has to check that it's legitimately that agent, it's not being man in the middle, whatever the case may be, that monolith application has to handle all of that, which means more load on that, which means more risk, et cetera. So enter where we are today. So I call it a SaaS hybrid. This application runs completely in AWS. It has the same client-server architecture with the client device. It does still send configuration data through the EC2 instances. So we are still using those. We got about 70 pools of these around the globe right now. So definitely a little bit of overhead on the operations teams at the moment. But what we introduced, and why I'm talking to you today, is we introduced IoT Core to feed back that event data. So we took that event stream, that event data stream, the EDR, et cetera, and we pulled that out. When we tried to push that originally through the left side, actually we started to have problems. We had lots of problems there. So we actually moved it out of IoT Core, or excuse me, into IoT Core, because we saw the capabilities of IoT. And once we got it there, then we saw the value and said, hey, we're going to do more. And I'll talk about that in a second. Today, that handles primarily our upload channel. So all of the data from the endpoint going to the cloud all goes through that. So when I talk about a new file is created on the endpoint, a new network connection, all of that telemetry data gets packaged up into a format, set over an MQTT channel back to AWS. We use IoT rules engine to then route that off to the proper destination. So that data never actually touches our monolith because it doesn't need to. So if we take today, and what are some wins that we got from this architecture? First big win we got, existing agents are stable, right? Our existing agents keep working. We still have that heartbeat or that existing EC2-based channel available. Most importantly, we limited the creation of new EC2 pools. So we haven't had to create nearly as many more as fast because as we've taken some of the load off of them, we've been able to not have to scale them up as fast. We use the existing channel to set up the new IoT, the IoT channel. So agent upgrade, it then establishes the trust for the IoT, the identity for the IoT component, and it gets pushed to the cloud. So it sets that all up inside of our existing channel, which has made the transition even smoother for us. It also enables that multiple to one data transfer pattern I talked about earlier. So if we have all the agents in this room, for example, they can all send to the cloud simultaneously because they're not dependent on waiting for a connection to be open on the monolith application. IoT is able to scale to handle all of those inbound connections and route them simultaneously to our backend processing. But this specific architecture isn't perfect. It does have some limitations. We still have to manage lots and lots of EC2 pools, right? We still got 70 plus of them globally today. That's not the cheapest to run from a cost or an operations perspective, right? Because whenever we do rolling upgrades, that takes longer for all of those endpoints or all those servers to get upgraded as well. The monolith is smaller, meaning we haven't had to add more to it to enable this, but it still contains a lot of dependencies for things like database access, et cetera, because there's still some of that core configuration data is still being routed through. So while it's helped a lot, it hasn't relieved all of that pressure on the monolith. So the monolith is still there. Let's talk about where we want to get to. So we've got a client-server device. We want everything going through IoT. We want to be able to retire the EC2 instances completely, and then have the rules engine continue to route data off to the proper AWS-backed microservice, trend microservice that we run in AWS. That's where we want to get to. The reason we want to get to that, the EC2 fleets are gone. We don't have to operate them. We don't have to worry about reserved instance capacity, all of that. That all goes away. It reduces the FQDNs needed for agent comms. You may say, why is that important? Many of our customers today, especially in their server infrastructure, their cloud infrastructure, they want to limit outbound connectivity. They want to know and they want to whitelist all the outbound connectivity from their servers to anything it needs to interact with. When you have 70 pools, that's 70 FQDNs. It's not a fun conversation for our customers to go ask their security team to whitelist 70 URLs when there could be 1 or 2 or 3. So it removes friction when they're interacting with other teams to get their technology implemented into their environment. Routing the traffic via the IoT engine. Like I said, we're breaking more and more of our monolith apart. We're using technology, products out there to help us break it apart. And as we do so, we can start routing that or breaking that data off at the rules engine versus having to go into the monolith. So the more of that we break off, the monolith gets smaller. The dependencies and the problems I talked about earlier with the database, et cetera, also become less critical for us. Agent jobs are not dependent on agent connections anymore because an agent does not have to talk to the actual application layer to get this command. It can be staged via IoT or in the message bus. So we don't have to wait for the application to process every job anymore in this model. Agent authentication is outside of our application. We don't have to handle agent authentication anymore. We still have to handle a little piece of the activation. Talk about that in a second. But we don't have to handle the authentication, the trust between the agent and the cloud. AWS IoT handles all of that for us. One of the many, many benefits. It's, like I said earlier, it's not differentiated, but it's core requirement for this technology, for our technology to work. But it's not the value that our customers are paying us for. So if we can offload that, which we have, that makes our life easier and lets us spend more time building features for our customers. Finally, it supports all those different data patterns that I talked about. So the one-to-one, if I need to send a job to a single endpoint, still can. If I need to have multiple endpoints send all their data to the cloud, already can. If I need to have one job sent to 50,000 endpoints, can do that. So now I've unlocked that speed, which is one of the critical things in security when you're in an incident response situation, is how fast can I get this information out to these endpoints or this block list out, et cetera. Now, like I said, there are some challenges that we still have to handle. So AWS IoT has been awesome. They do great things for us. But there's some unique things about our use case that their standard offering does not handle. And that's fine, right? But it's helped us a lot. But here are some of the limitations that we found. Agent reactivation and cloning. If you think about a traditional, what you'll think, and Sham will talk about this in a second, this isn't what you would think about if I say name an IoT device, you're not going to name an agent installed on a desktop traditionally. right? So you get a little camera at home or whatever, it's got a serial number, it's got a hard-coded identity already. Well, if you look at our use case with an agent in the cloud, many of our customers will bake the agent into their AMIs, right? That they clone and then redeploy, or in their VMs on-prem, or their golden image that they deploy on-prem to their laptops. Well, if that has an identity already baked in, that means you have 2 or 3 or 4 agents calling back to the cloud with the same identity. That's a problem. So how do we handle effectively rekeying or creating a new identity for those agents, identifying when it is truly a new one and not just one that moved places? How do we handle all of that reactivation and that cloning effectively that is common in the endpoint market? Offline agent message queuing and retry. So IoT is great, but we have a lot of volume that we're trying to push through. How do we queue that and make sure that no data is lost ever? In a security situation, customers can't afford logs to be lost. So how do we make sure, especially when we have multiple teams trying to push all of their messages through a common module, how do we make sure we have a way to basically queue that up internally on top of what AWS already offers? Agent is offline, or an agent is on a plane working, it's still generating that data. How do we queue that to make sure when it gets connected, it gets sent as effectively as possible? Last but not least, large file transfers. So MQTT, great technology, has a size limitation. It's part of the protocol, totally fine. In our use case, when we use it for things like collecting a file from an endpoint, maybe it's a malware file, et cetera, those files are very rarely less than 128 kilobytes. So how do we then transfer those files? We've internally built technology that basically chops the files up at the agent, sends them as individual MQTT messages, and then we recombine them on the cloud and drop it into validated via hash, and then drop it into an S3 bucket. So that's one of the problems we chose to solve. Other companies, other ways we looked at solving it would be, what if you just upload the file straight to an S3 bucket? Works, totally works, we've done it. But now I need more FQDNs. So now I've added friction to other parts of my customer's process. So by using MQTT, doing a little bit more work there, we're reducing friction for our customers in other ways to make their life easier, and also to make our application simpler with less channels to the cloud. So why IoT? Why did we choose IoT? Hopefully it's become kind of clear some of the things. AWS handles the scaling, the agent server retry, the connection security, all of that. AWS has taken all of that on, which is awesome. So we just activate a device to IoT Core, and they handle all of that connection going forward. We've actually enabled our internal teams to run faster, because now they don't have to worry about networking. We're in the process of having what we're calling like an agent SDK. So if a new team wants to add new functionality to the agent to add more value to our customers, they request a topic be added to that IoT bus, and then they integrate with that agent SDK to send their data to the cloud, and then we add something on Rules Engine to route that data on the cloud to their application. So it's removed a lot of friction. The goal that I set for the team was never to have to rebuild server agent communications ever again. This is a way to do it. It meets our needs. There's no reason for other teams to have to reinvent this wheel, because it's, like I said earlier, it's an undifferentiated value, but it's a core value that has to be there. So why keep reinventing the same wheel? We can communicate to multiple agents more efficiently. I talked about that many times, so I'm not going to go too deep on that again, but it has really helped us reduce load on our system and get jobs or get tasks to agents faster. We've actually seen that in our data. Because we can dispatch that task to multiple agents as the destination. So when I want to send a job to 30 endpoints because they were exposed to some threat, I can do that simultaneously with one job or one task in the system, not 30 like I used to have to do. And most importantly, multiple agents can report data back in at once. Don't have to worry about all of that going through the monolith. I can have multiple connections coming to IoT at once, and then I can route them off to the side using Rules Engine. It's been very, very effective for us. There's Rules Engine again, right? So routing the data where it's needed. So as we add more things, more teams that are adding, it's just another rule to route off their topic to their destination, be it a Kinesis stream, a bucket, whatever the case may be. Rules Engine has enabled us to send all of that there. It's completely moved the routing logic out of our application. It used to have to go in the monolith would write it to the database, then other parts would have to go access it. The monolith doesn't even know this data is coming in. It doesn't need to know, and that's the beauty of this solution for us. So where are we going next, though? So we've got this. You've seen the goal for this specific product line, but there's other use cases we've discovered internally, too, that I wanted to mention. AWS IoT Greengrass, so moving some of the processing closer to the agents. If we can get, many of our customers want us to put or are fine with us putting a small VM on-premise for them or in their data center, that they can then route all of the traffic for our agents through. So it all goes through that proxy, and we can do some pre-processing there. Where that benefits Trend is that means that's less cloud processing we have to do. It uses some of the customer's compute. However, it also allows us to provide value faster and start doing correlations on-prem if we choose to. It also limits the outbound connections. So instead of all of the agents having to talk to IoT in the cloud directly, now it's just Greengrass that talks to it directly, that appliance or that software application. The agents go to that, it queues up, and then it will send is kind of what we're thinking right now. But we also want to go beyond AWS IoT, beyond just the agent use case that we have, but are a bit closer to IoT-type devices than the virtual agent. One being network appliances. So Trend has a large network appliance business as well. Can we use this to manage those appliances versus the traditional model that we use today with the server-client architecture? Can we send this traffic over this as well to standardize, to solve some of these same problems for those other teams inside of Trend? And finally, a new team inside of Trend looking at vehicle security, called Trend Micro VIC1. AWS IoT has lots and lots of cool things regarding vehicle Sham will talk to it about just a second with things like FleetWise, et cetera. So the whole line of ways to do IoT connected with vehicles, looking at ways we may be able to integrate and provide security at that level. And with that, I would like to invite Sham up to the stage.
Thank you, Eric. Hi, folks. Everyone hear me okay? All right, very good. First off, thanks, Eric. Lots of great stuff there. And I want to call out one thing that among the slides he showed, the 2022 Global Marketplace Partner of the Year. Because that doesn't come by accident, right? That comes because they've got a focus on security, something that is important to pretty much every industry you can think about. And being able to help that and think about how do I innovate on top of AWS, use AWS to offload some of my work, get that time back, and focus on differentiating for their customers. So thank you for that, and really want to call that out. The other thing that is selfishly useful for us is having customers and partners like Trend Micro who actually go deep and think about how to optimize their systems, how to take the unique value they get and accelerate innovation within their teams is great because they're engaged, they give us feedback, and if you're customers of AWS, give us feedback. I think you've heard this before, but it's worth repeating. 90+% of what we do is driven by what you need. So we're always eager to hear from you. And so the rest of this talk, if any of you attended my talk yesterday, I talked a lot about AWS IoT and the Internet of Things. There'll be a little bit of a repeat there, but there'll also be a lot of interesting things that I think will dive deeper into this use case and patterns and so on. And Trend Micro being able to see that their thing is not really a thing, but still apply that design pattern of IoT and then use it is great. So a little more background on me. I'm the general manager for the consumer IoT and connectivity team in AWS. My team runs services such as IoT Core, device management, device defender, IoT Core for LoRaWAN. And I've been in the IoT team pretty much since we started it. So as I tell my team, if there's something you like, I'll try and take credit for it. If there's something you don't like, I probably am to blame. So let's dive in. So AWS IoT is really what we're here to do is look at customers who are trying to innovate all the way from the edge, innovate in the physical world, try to make the physical world better in a whole bunch of domains, from smart home, smart agriculture, smart manufacturing, smart cities, and use the power of that cloud to understand and interpret the physical world, improve that physical world, and drive changes back, either manually or real-time control systems that improve the world. So that's what we're here to do. And when we started this journey, right, we talked to a lot of customers. And the first thing I want to talk about IoT is you'll see this slide with a whole bunch of acronyms right here, is because IoT is broad. right? When you think about a device, think about your simplest IoT device, maybe it's a smart lock in the home, right? And it requires hardware. It requires firmware that runs on this little microcontroller. It requires some sort of communication technology and battery conservation, because you don't want to replace your battery every day in your door lock, to some gateway in the home, maybe a smart home hub. That has to talk to the cloud. The cloud has to make sense of that data. Maybe you have a smart phone application to control it. You've got operators who have to diagnose these devices if somebody calls in saying they have a problem. And so IoT, whether it's a smart home or a smart factory, ends up having to span so many disciplines, from device building and manufacturing, communication technologies, wireless, wired, different communication protocols, the cloud services, understanding that data, making sense of that data, and then driving that back. So as we talk to a lot of customers in these industries, we found some patterns that are very similar. And we've built foundational services that I'll walk through today to help customers solve these problems in all these domains. We also ended up building certain services that are purpose-built for specific domains that are unique. And I'll talk a little bit about those. So let's start with this little diagram here. On the left, we've got design, manufacturing, edge processing. So we want to make it easier for people to build connected devices and make them safe and easy to connect to the cloud. And we've got the full range. We've got SDKs. We've got a full operating system that runs on microcontrollers, sensor-based devices, and actuators. So FreeRTOS, fully free, open source. It's got libraries that we have that you can use to connect to the cloud. We have Greengrass, third in that list, which is for gateway class devices. You might have a lot of devices in the home or in the factory that are connecting through a gateway and aggregator. So Greengrass allows you to really do local processing, aggregate data, and send that to the cloud, and gives a lot of really useful runtime libraries, or such as Stream Manager, which buffers data for you and handles disconnects, such as machine learning inference. Maybe you've got connected cameras that you want to do human detection on, and you want to run machine learning inference. So there's a lot of capabilities that we bring to the edge. And ExpressLink, which allows customers who are making connected devices to not have the full stack understanding. Okay, here's the library, here's TLS, here's TCP/IP, and so on and so forth. And then in addition, think about all the cloud connectivity libraries. ExpressLink is a family of modules that traditionally, when you were building devices, you would add a wireless module or a cellular module. We encapsulate all of the libraries required to connect to AWS into ExpressLink. And we just actually added new modules from Realtek yesterday, added device shadows, device defender. So you've got this little physical module you can solder onto your device design, and it takes care of just connecting to the cloud. You send it, the module, a piece of data, it's in your AWS account in the cloud. So we've got services at the edge. And then in the middle, you see the actual connectivity, registration, data processing services. So once you get that data to the cloud, or even how do you get that data to the cloud over different networks, we've got services that help you there. I'll skip IoT Core because I'm going to go super deep in it in the next slide. But we also have Kinesis video streams if you've got camera data you want to send. We've got Device Defender if you want to secure your devices, get data from these devices from a security posture perspective, detect anomalies. And analytics services to make sense of that data. And lastly, you want to be able to say, if you've got a device, a fleet of 10 devices or 1 million devices, you have to manage it. You have to understand and organize that. You have to send commands to these devices. You have to update them. And so we've got services for device management. In addition to these, I also mentioned that we have purpose-built devices for specific verticals. So TwinMaker, SiteWise, and FleetWise really help our customers in industrial verticals or automotive verticals have specific services that, in fact, use a lot of these other foundational services underneath to provide additional value. FleetWise is for making sense of automotive data. SiteWise is for making sense of industrial and manufacturing data. And TwinMaker allows you to actually create process and operational twins that aggregate and give you a semantic understanding of the physical world. So you can model your factory, integrate camera streams and equipment data, and so on. So we've got this wide range, and IoT has this diversity. But key to this conversation is IoT Core. When we're thinking about devices that are in the field and they want to connect to the cloud, oftentimes one of the characteristics that these devices have are they're constrained in some way. So we wanted to make sure that constrained IoT devices have a way of connecting to the cloud and easily taking advantage of all of the capabilities that the cloud has, storage, machine learning, and so on and so forth. Because only when you use those do you actually make sense and make those just simply connected devices into smart devices, right? And so I want to zoom in on this second, third, and fourth box here, the device gateway, message broker, and the rules engine. So what we have in those is we have a managed device gateway. So all the things that Eric talked about, EC2 instances, load balancers, and so on and so forth. We've got a managed service that takes care of that for you, right? And we do the scaling, and we are able to have sort of advantages and efficiencies of scale and pass on those cost savings as well to our customers, and also the development savings, so you don't have to think about that. So if you use a device gateway, we'll essentially provision, you go to our console, you say, I want to use IoT, we'll give you an endpoint. And that endpoint supports MQTT, it supports HTTP, it supports WebSockets, because different IoT devices, as I said, there's a lot of diversity in IoT. They all connect to that endpoint. They can authenticate through certificates, through IAM, through Cognito. And so multiple ways of authenticating, multiple ways of connecting, but we manage that, and this endpoint is all you need. And devices can connect to this endpoint, and if you go from 10 devices to 10 million or 100 million agents, we'll take care of scaling behind the scenes, so you don't have to worry about that. The message broker, which if you're not familiar with MQTT, it's a publish-subscribe protocol. It's very well-suited for low-power IoT devices, very constrained. But it's also a very good control channel. And so message broker really is a publish-subscribe broker, so you can send messages between devices, from applications to devices, devices to applications. And again, it's auto-scaled for you, so you're effectively just saying, I'm going to send a message on this topic. You have 10 listeners, they get it, and we take care of all that message distribution. And the last piece is the rules engine, right? We talked about how IoT really comes to life when you take advantage of the data storage and analytics tools in the cloud. And the rules engine takes data from our message broker and allows you to integrate with over 20 different AWS services, including some non-AWS services, and send that data. So you can just essentially configure a little SQL-like snippet inside the rules engine, and you can say, well, there's temperature data coming in from this device. If it's more than 20 degrees, send a notification through SNS, right? If it's otherwise, just send it to DynamoDB for storage or S3 for archival. And so just simple rules, it's all managed, it's all serverless. And the last piece I wanted to mention on this slide is IoT patterns are often either streaming or event-based, right? And so devices are doing nothing for a while, and then they're doing something. Once in 10 minutes, they want to send some data. And so these patterns allow us to be able to say, managed serverless technologies like IoT, plus services like Lambda, really allow customers to then focus almost exclusively on their business logic and their application logic, and in the case of Trend, really focus on adding security value to their customers while we take care of that. Last thing I want to also mention here for IoT, and I'll come back in later, is there's long-range connectivity services. Sometimes you're operating at a semantic layer, MQTT, HTTP. Sometimes the physical connectivity of IoT devices is different too, and we've got services for that. So in summary, IoT Core is basically this portal between the physical world of things and all the cloud services that really allow you to take advantage of data, right? So that's the overview. We'll dive a lot into sort of design patterns and back to the topic of this, but I wanted to give you an overview of what we've got in IoT and how it's relevant to this. Obviously, we've got lots of customers using that successfully, including Trend Micro. And you'll see, if you just look at the little icons here, they're across a range of industries, right? And all of them, our hope is that they're able to differentiate for their customers, make their customer experience better, and obviously get great business outcomes like increased revenue, saving money, and accelerating their innovation. And we see, as I said, lots of domains. Smart homes, healthcare, energy is a very active conversation nowadays, and we're seeing companies really as they manage this transition into renewable energy, and how do you interoperate that with the grid, how do you do microgrids? Lots of customers in this space using IoT, because again, anytime you see the physical world, whether you see it or not, IoT technologies are underneath the cover. And we've got large-scale services. As I said, we scale behind the scenes and sort of pass on those efficiencies of scale. every day we've got 45 billion plus messages. So it's over 1 trillion messages every month going through our systems. Lots of partners, so IoT is not sort of a solo game. When I talked about devices plus hardware plus wireless technologies and all of that, you really need multiple people to come together to form these solutions. So we've got a great partner ecosystem, lots of devices that have been qualified to work with us, and continuous innovation as well. So great. So that's IoT, a little recap for those who didn't know about it. Coming back to this, right? So we want to talk about Trend Micro and how they were able to use it. Well, let's start with the thing, right? Very generic term, but often we talk about devices. What's a device anyway? And why does IoT need something different than laptops and servers and traditional IT? And there's two things. When you look at the physical world and what people are doing, oftentimes these devices are constrained in some way. If I want to put a $1 chip into a toothbrush, right? It's going to be CPU constrained. It's going to be battery constrained. It's going to be, if I'm going to put it in the middle of a farm, it's going to be bandwidth constrained. Sometimes it's going to be disconnected for lots of time. We have some customers who are doing sort of middle of the ocean transit containers, and then they'll send data up when the satellite goes overhead, and the rest of the day it's just not connected. So you've got lots of these constraints that you've got to handle. Traditional IT systems don't expect that, right? You have gigabytes of storage in your servers. You expect almost 99 and 4 nines availability and storage durability and so on. So when you've got these constraints, there's custom protocols. And MQTT is one of them that we talked about where, you want to send a message and an HTTP message, there's 500 bytes of header. In MQTT, you've got less than 5 bytes of header. So we're able to provide easier technologies that solve IoT, and then we bridge that, as we talked about, to the rest of the cloud using IoT Core. IoT devices are also often, and we'll talk about the exception here with Trend Micro, they're single purpose, they're highly customized, right? I made a custom device to sense vibrations on a conveyor belt so I will know whether it fails before it fails, and the technician can go out and save money. I have a custom humidity sensor in the farm that's going to tell me if I need more water in a particular segment of the farm. So really cool, great applications, but they have this sort of single purpose, and then you got to integrate them all the way to the cloud. So we essentially tried to solve for these challenges in AWS IoT, right? And so we built these systems with these in mind, and at that point you go, great, you're talking to me about devices. Trend Micro's agents run on a laptop, right? Why does any of this matter? I think that's where both sort of the design pattern matching and innovation that Trend Micro does comes in, but also the specific patterns that you see in IoT Core come in, because these same technologies that we ended up building for IoT apply to a few other domains, right? So I talked about that serverless model, event-driven model, and streaming model. IoT devices, because they're in that nature, agents are the same way. They're sending telemetry. They're basically sensing what is going on in the laptop around them. So your agent is effectively a sensor inside the laptop, collecting data, and you want to make sense of that data and give customers useful insights from it. From that sense, it is an IoT thing. It's just a virtual thing written inside your laptop. The publish-subscribe model that is very useful for MQTT is also useful here when IT companies try to scale and have multiple teams trying to build platforms, because it decouples this notion of the producer and the consumer. So your agent team that is building agents, collecting more data, can start doing that at a different pace and at a different timeline, and even opening up without even knowing what the possibilities are in collecting that data from the teams that are producing it, from the teams that are creating tools to visualize it and send it to your BI teams and so on and so forth, right? So you get that decoupling, and that's a great pattern as well that IoT systems do. The MQTT protocol, and we just launched actually MQTT version 5 earlier this week, which is a significant upgrade over the previous version, got a lot of cool features. And it enables lightweight control channels. So you want to send down new configuration to a device that says, well, I collect data points A, B, C, and D. Now I want to just update it to also collect data point E. Well, you can use MQTT, you can use our device management jobs feature and send a single message to the message broker. It'll fan it out to 5 million devices and say, well, all of you, you've got a configuration update. You can schedule it and say, okay, well, I'll apply that configuration update at midnight. The next day, you're collecting that extra data point, right? So all the things that we built ended up being useful for this use case. And of course, the rules engine we talked about allows this easy integration, right? You can send that data to Lambda functions. You can send it to S3, Dynamo, and so on and so forth. And the last thing, and very relevant to the security space, is you'll have customers of IoT come in and say, well, I already have specific rules of which devices are allowed on my network and so on and so forth. When I send it to your endpoint, how do I know that this device is allowed to do? So we actually built some features called custom endpoints, custom authorizers, and so on and so forth, where we will authenticate these devices with TLS and the certificates, but we'll also call out into your sort of pluggable authorizers and say, well, can this device do this operation that it wants to do? And that's great, because when you think about, again, enterprise IT scenarios, there's a fairly complex environment, right? You might have a Trend Micro agent authenticating the problems you want to solve, talking to IoT, but you may also want to go then and call out into the individual enterprise's SSO layer and say, is this person allowed to do this particular action? So you have these enterprise trust relations that can also be modeled and very similar to the IT world. So I just wanted to call out these similarities. We're excited to support Eric and team in that. And the last thing, if you're thinking about using IoT or just innovating your architecture and some of the great principles that Eric outlined, some of the things we've seen are worth repeating. Decoupling clients and applications accelerates your delivery velocity and innovation. With IoT, we're able to abstract that network so you can focus on the application layer. You add new clients. We handle the scaling and elasticity. On the right side, you sort of see the whole reliability, elasticity, scalability, security that we take care of for you. The last piece I want to leave you with here is best practices. I think when we get into the details, even if we're taking care of a lot of things on IoT on the cloud side, and we provide SDKs on the agent side, IoT solutions, or even in this case, virtual thing solutions, the true resiliency that what the customer sees has a connection all the way from the individual client application through the middleware all the way to the cloud. So error handling and retry policies are important at every layer. Being able to test through that is very important as well. So there's a couple of things I want to call out. So Device Advisor is a free service that we offer for all IoT customers. And what it does is when you provision your endpoint, we'll give you a test endpoint. And you can go and configure a set of tests to say, well, when my device connects or my virtual agent connects, actually give me an expired certificate. And we'll actually give a fake expired certificate and make sure that the agent disconnects instead of trusting the service. You can set up a test that says, well, force disconnect that network, and we'll see if you're retrying. Are you retrying properly? Are you retrying with backoff, exponential backoff, and so on? So there's a lot of good policies that we've encapsulated into Test and Device Advisor, and it's a completely free service that you can go and try out, and it'll really help make your applications resilient as well. So Device Defender Audit is another service that I want to just plug a little bit, because you've got security on the agent side. You've got a lot of network security tools that Trend Micro provides. But once you use IoT Core, you could still have certain configuration that would be more open than you may want in your organization. So Device Defender Audit is a set of checks that we do against the way you've set up your policies and your certificates. Make sure you're not opening these policies up more than you would normally want, and we'll just flag it to you so you can go and fix those as well on both at an account level and a per device level. So that's pretty much it. I'm very excited that we're able to solve real physical world things and also virtual things with our platform. And big thanks to Eric and Trend Micro for leading the way in innovating in security.
Thank you, Shyam, for joining me.
Thank you all.
With that, I think that wraps up our session here, and hope you enjoyed it.
Thank you.